So if you look at the SAP HANA server, it could be or multi-node cluster. So when it says single host, it will be single server, single motherboard. But if it is multi-node, it will be a you will have one server as central instance and multiple motherboards. All together will represent one server. That is multi-node. And each node would have all these components. As it is, you will have the database software and you have other software supporting it. Now, for example, if you look at SAP HANA database software, you would have servers like index server, processor server, name server, statistic server. Then there's one more which is not there, which is here. X will also have that also. Now each server of specific purposes. When it's a server, it's all about programs, set of programs built in which handle certain kind of activities. Yeah? So when you look at index server, this is mainly focused on handling the entire database. Let's say you create some table, you manipulate data into the tables, you committing, rollback, all those database management is all done by handled by your index server. And then you'll have a server called pre-processor server, which basically takes care about processing your unstructured data. Then we'll have something called text analysis, full text index, which basically takes care about processing your unstructured data. That is your pre-processor server. Then you'll have something called name server, which basically takes care about landscaping. For example, real-time environment, you'll have dedicated landscape with development, quality, production. Setting up the transport mechanism or HANA content transports is all handled by your name server. Then you'll have something called statistics server. Like for every operation you do in HANA, it does collect the statistics into some repository tables. And then later you can always view the statistics of the operations, what is happening. So statistics server main responsibility is about collecting the statistics of every operation you do in HANA database. Okay. And as it is, you will have Access Engine again, Access Engine server, which basically deploys, you can deploy and develop your applications on top of Access Engine, whether it is native or non-native. And then you'll have SAP car. It's not a big software. It's like just like an exe, like WinZip software. So most of the software what is given by SAP would be in .sar, .car files. To basically unzip those, we use a software called SAP car. That is an exe file. By using this exe file, you will uncompress those .sar files. And then by using your host agent and your LM, life cycle management, you can do all the kind of administration, transport connections, all those can be done with the help of life cycle host agent. When I say host agent, in a multi-node architecture, you should be having one central instance, multiple dialog instances. So host agent in a node where you have host agent, that is considered to be central instance, and all of the servers will be considered as dialog instances, and all together will represent your server. Okay? Then you'll have solution manager to handle the entire project implementation or documentation, transport, everything can be done from there. Then we have HANA Studios. Normally we install SAP GUI to get connected to the SAP servers. Say you have your HANA server installed and sitting at the client place, you would like to get connected to the server place. So what you do, client system, you will install SAP HANA Studio client software, which is basically an Eclipse based tool. From this HANA Studio, you start getting connected to the server, to your HANA server and start working on it. HANA database server ఉంటుంది. So you're at the client system. So in the client system, you would basically go about installing HANA Studio, which is a client software, which is basically an Eclipse-based tool. And once you install it, you can start getting connected to the HANA server and start working on it. So if you see now this Studio is a client-based tool. And from this, I get connected to the server and then start working on to the HANA database. Yeah. And then we'll have some repository. When I say repository, it's all server space, is what we call. You develop some applications. If you want to run them on HANA server, you have to deploy them onto repositories. Means you have to place them onto repository into the server space. And also, when HANA is a database, you won't create lots of database artifacts, say tables, views, procedures, column views, all those stuff. When you say right click and say view table, you would get to see like matrix, but internally doesn't store it like this. So there will be a lot of system-based tables which does store the entire metadata of it. It again standard tables, which is what we can refer them as a repository. So when you install your HANA database, there are ready-made standard tables built in, which will be formatted in a schema called sys. You'll have a schema called sys, which will have all the system-relevant tables in it, which holds the complete metadata of your HANA database. Let's say you create some table. Definitely in sys schema, there is a table which holds information about all the tables. And in sys schema, there is a table which holds information about every column of a table. There is a ready-made system table in sys schema which holds information about every procedure or every column view, every views. All those ready-made, all the metadata is always stored into some backend tables of the system, which is actually maintained in the schema called sys. Yeah. That is what we refer to server space. That is what we call them as repositories. And let's say you create a lot of HANA content or HANA models like attribute views, analytical views, calculation views, and you save them into the server space. That is what repository. Then, like any other software, you would have an update manager, basically, which updates your software update manager. So all these components together we refer to as HANA appliance. Okay. So it includes database and other external softwares into it. We call this HANA appliance. And when you have multi nodes like this, we call this multi-node architecture. And if you use single node, it's a single node. It's one server, but multiple nodes in it. For example, let's say in one motherboard you have to bring in 4 terabytes of RAM. But as per your sizing, you actually wanted to have, let's say, 12 terabytes of RAM. Then what do? You go but come 3 motherboards into it. And in each motherboard, you would have index server 1, index server 2, index server 2. And all these 3 will constitute one server. Server need not be one system. It could be multiple systems together contributing to one server. So when you have multiple nodes, like node at each system like that. So then one node will be referred as central instance node and others will be a dialog instance, distributed system. Yeah. Then you go by having multiple index. If I have 5 nodes, you will have 5 index servers. Okay. And that is where we was referring to partitioning yesterday. If I have multi-node architecture with 5 index servers, I can partition my table across 5 servers, 5 index servers across. That's it. Okay. So now if you look at this one, we're trying to open up index server. So index server is the one which basically handles the entire database. So what all components or what engines does this index server have in it, which takes care about processing of your database. Okay. Now if you look at this, you have something, this block of it. Look at this. This block of it is what we have not even hold till here. This block. We refer with the index server. Okay. We'll have something called session management, transaction manager, authorization manager, metadata manager. Then we have got replication server integrations. Then we have request processing engines. Then we have something a persistency layer and the disk storage. Now, someone asked me, does your HANA store data only in main memory? No, it does store data in main memory as well as disk also. And that's what I was referring to, this disk. When I said disk storage, this is your hard disk. So your hard disk will have 2 storages. One is your disk volume and one is what? Log volume. So let's discuss on all these components. Let's say you have an index server and as a user you're getting connected to it and you are trying to run some queries on it. Let's say HANA has got some database tables and you're getting connected and you're trying to run some querying. You're doing some querying on top of it. So how does it happen? So when you want to get connected, do you basically specify your username and password and then get connected with us? So when you basically try to get connected with some username and password, you will have this component utilized. Authorization basically checks the authentication of the user and allows you to log into the system. Now, once you get connected, it establishes a session. And the screen, the screen you log in is a session here. And all that session is managed by your session management. You get connected, and authorization manager checks the authentication of it. And once you are authenticated, you session established, and that is what managed by your session. And we can see how many number of sessions is being active. Then, okay, boss. Once that is done, let's say now once you get connected, you're executing a query. Say select so and so from table. That's the query running. So is it a request sent to the server? In HANA Studio, you logged into HANA Studio, you connected to server, and you're running a request saying select so and so from table. That's my select query. So will that select request sent to your server? And this request is sent to server. In the server, this request is processed by this block. Look at this. Request processing or execution control. Suppose, say, while writing select, I've done some, there's some error in this, there's some syntax error in my select statement. So what is the response you get? Saying this statement is invalid and this, you have some error in this column. So now look at this. So every query you run in, it sends request to the server, index server, and index server takes in that request by this block, request processing and execution control. Once the request comes in here, you'll have an engine called SQL parser, which basically checks the syntax of your SQL. It just checks validates the SQL statement. If there's some error, it returns back with the error, say, could not execute the statement or not. You get some errors out here. Suppose if the SQL parser passes through the validation that this query is fine, then that gets onto the engine called SQL script, which basically executes your SQL statement and gets the result back. Suppose if the SQL statement contains some complex calculations, it does leverage your calculation engine to execute those operations. Okay, calculation engine is leveraged only for performing complex operations. So while performing SQL script, if it encounters any complex operations which it is not able to handle, then it does transfer the load onto a calculation engine and executes. Because while doing models, you have an option of executing those views on SQL engine or calculation. There's slight difference in execution of these engines. How they deal with the null operator is slightly different. You'll see that. And then let's say you're running some query with MDX query, not the SQL query. Then that will be handled by your what? MDX processor or MDX engine. Because HANA would expose the objects in two interfaces, SQL or MDX. Let's say you're running a report which is interfacing through SQL, then SQL engine is taken care. If you're running a report from an interface which is consuming through MDX query, then it does pass MDX query to the HANA server, then your MDX engine will take care about executing that particular MDX query. Okay? And apart from these two engines, there are two more engines which is not in the screen. One is join engine and overlap engine. Yeah. Other day we've seen that once to HANA, on top of these tables, you start building up the HANA models like attribute view, analytical view, and calculation view. So when you fire a query onto attribute view, it does leverage something called join engine. When you fire a query on analytical view, it does you leverage something called overlap engine. And when you fire a query onto calculation view, it does use calculation engine. But still, let's have calculation view. I would like to have this execution done in SQL engine. I have an option where I can set up, say, execute in SQL engine or execute in calculation engine. There are some benefits what you get if you execute in SQL engine. There are some benefits what you get if you execute in calculation engine. They're basically on the behavior of the null operator. Calculation engine treats it different way and SQL engine treats it different way. Okay. And one more benefit is, let's say, you build some you don't know, but when you build some calculation, you go about doing a lot of joins. Let's say I would like to build my view where I would like to join 5 tables. Then how do you build this? First operation, join table 1, table 2. Next operation, the result of this to table 3. Next operation, result of this to table 4. Next operation, result of this to table. Like this, you go and you end up 5 joins, 8 joins, 9 join operations. So if you execute this in calculation engine, what it does, For each operation, it does form one separate select statement and execute those select statements individually one by one. Like we'll have layers of calculations. Say block 1, block 2, block 3, block 4, block 5 join operations will done. So when execute through calculation engine, what it does for each operation, it does form a separate SQL statement, executes this block by block. Okay. But if I say execute in SQL script, what happens? It takes the all it will have SQL statement for each operation, right? It combines all the SQL statement into one big SQL query and runs it. So what is the benefit is, let's say when you're running, when it forms a big query and executes it, it can do some precedence of the join. And the logic is that, let's say you're joining 5 tables, table 1 to table 2, then the result to table 3, result to table 4, result to table 5. Let's say you're doing all inner joins. Okay. The logic is that, let's say the table 5 has got only single record. Okay, let's say table 5 has got only single record and all this table 1, table 2, table 3, table 4 has got millions of data. And let's see if you execute with calculation engine, it does not worry about the precedence at all. It just goes by sequence. Let's say table 1, table 2 with millions of data are joined, then that is joined to millions of data of table 3, then it is joined to millions of data of table 4. Then the million results are joined to table with one record, then output is what? Single record. I may not unnecessarily process, ultimate output వచ్చే ఒక రికార్డ్ కోసం ఇన్ని మిలియన్స్ ప్రాసెస్ చేసినా కదా. But if your SQL script what it does, it formats one big query with all the joins, and then it just checks the precedence of which join has to get executed first, so that my performance is faster. Then it executes the join of my table 5 is included first, so that the number of results have gone down to 1. That's the concept. It gives me one big query with all the joins. Then it does check the precedence of the join. At the join execute, they say first it execute that particular join. So join precedency and then behavior of null operator. Through that you define whether I use SQL script engine or should I use calculation engine. Clear on this? So join engine will be leveraged when you want to fire a query on attribute view. OLAP engine will be used when you want to fire out a query on analytical view. There are some 3 types of views. Okay. So by default, calculation engine is used for calculations, but you can still leverage it to use what? SQL engine also. Okay, good. So ultimately, when you're running these queries or views or models, all these are based on some tables in the backend. Let's say you build a model, analytical view or calculation. It's all based on tables. Let's say you run a select statement. It is all based on database tables or views. When it comes to tables, you can have either row store tables or column store tables in HANA. If you have you find a query on a column store table, it does use column store engine to process or read the data in from the column store. If it is row store engine, it does use row store engine to read data from the row store table. In fact, row store table will have different set of data types. Column store will have different set of data types in terms. So it needs a dedicated engine to understand those data types. But in HANA, when you are creating table, you would see it as normal. Let's say you would see data type like integer. Okay. So let's say you create a column store table. Internally, see, there is an interface engine column store which will convert those integer data type to column store specific data type like CS underscore int. For column store specific, the data type is CS underscore int, but normally you get to see as integer. For row store, it is normal integer. So column store will have its own column store specific data types. So it needs a separate engine to convert those normal data types to column store specific data types and handling the data processing from column store tables. You getting this? So you have a dedicated engine to handle column store tables. You have a dedicated engine to handle the processing of data from row store tables because of its own specific data types or the architecture what is maintained in the backend is different for both. But for you, when you're creating a table, you will never see anything different in the data types used while creating those tables. Either you're creating row store table, either you're creating column store table, you will still use the same set of data types, but internally it does convert that to a different set of data types for column store table. You can see what is mapping of data types from normal data types to column store also. Okay. So then it does give in this. Then now See, normally you heard about what acid. Any database should satisfy the property like acid, atomicity, durability, isolation. Yeah. Yeah. When it's atomicity, let's say you have some transaction. If it is done, it has to be done completely. Otherwise, not to be done at all. Let's say I'm trying to withdraw some amount from account one and trying to deposit to account two. So after I withdraw amount from account one, and let's say there is a power, you lose power, and then you're not able to process any transaction. Then this has to be rolled back to the status bank. Double డబ్బులు జరిగితే ఫీజు ఎక్కడన్నా పెట్టాలి లేదా అసలు జరగకూడదు. So that is all handled by your transaction manager. By using commit and rollback, we'll have things like commit and rollback, which takes care about that atomicity. Whether if the transaction is done, it's completely done, or if not done, nothing is done. So that is all handled by your transaction through commit and rollbacks. It handles the transaction processing in your database. So there's no data discrepancies with that. Good. Then there's something called durability. When I say durability means, let's say I have a database. If I store some data into it, I should see this until I delete it. The data should be stored permanently until I delete it. That is what durability. Enroll data clear. That is what I mean as durability, right? Now, when it comes to SAP HANA, it doesn't store data in main memory RAM. Yeah. So RAM is volatile or non-volatile? Volatile. Current పోతే వెళ్ళిపోతుంది data. If there is a power loss, then you see the data in the RAM is lost. So now the point is, how does my HANA guarantee the data persistency, even though it stores data in main memory? Or how does my HANA database satisfy the durability property, even though it stores data in main memory? Yeah. So actual concept is that even though it is in-memory database, every read happens from main memory, but every write happens to main memory and to the disk also. That's the concept. So since it is able to write back things to the disk, if there is a power loss, when you restart the server, the data from the disk is again loaded back to main memory. You're not losing anything. Even though it is in-memory database, logically internally what happens? Every read is from main memory. Every write would happen back to main memory and back to disk also. So when there is a power loss, when you restart the server, you can get the data back from disk to main memory also. So how is that done is what we're trying to understand. Okay. No, let me just discuss on it, then I'll come. See, for execution is different. Data inserts, let's discuss on this. Yeah? Actually, you see, we have two disks here. One is data volume and log volume. These are two hard disks, okay, within your server. Okay, there are two separate hard disks. Okay, and then so that's why it says disk storage. This is not part of RAM. Right? Then there's something called persistence layer, which will have something called page management, and there's some other component called logger. The purpose of page management is in main memory, the memory is always addressed as pages, 8-bit page, 16-bit page. It's always the memory is addressed with page numbers, pages. So what the responsibility of the page management is, it can, let's say you've done some change in some memory. If you're changing some record in some table, is it affecting some memory in my RAM? No, table or record మారుస్తుంటే ఆ రికార్డ్ ఏ మెమరీలో ఉందో ఆ మెమరీ మారినట్టు కదా, అండ్ మెమరీ RAM memory will indicate a page, and through page management I can identify which page is being modified or which address of my RAM has got a data change. So through page management I can identify which page has been modified in the RAM. Okay, good. And then there is a component called logger. Okay, page management will identify the change in the memory address and sends that log to what? The logger. And logger will insert that log into log one. So for every transaction you do in the database, page management will identify the change and pass that change to logger, and logger will insert the logs into what? Log one. For every transaction you're doing, you have the log of it. In what? In the log one. That it will be storing like it. Okay. Now let's say now server is not switched on. Let's say I had only one table with 5 records. Okay, and that will be initially in what? In the disk. Okay, now let's say you start your server up. Okay, and actually it will load that, but when you start the server, the table with 5. Let's say you actually written a command saying load this table. And when I say load this table, the table with 5 records is loaded to what? Main memory. Now in main memory I've got a table with 5 records. Even in the data volume, I've got a table with 5 records. Okay. Let's say now the time is 11 o'clock, and they use a concept called save point. When you execute the operation called save point, it does save the data from main memory to disk. Let's say I'll execute the save point for every 5 minutes. So now the time is 11. The table in main memory and the disk both are in sync. 5 records, 5 records. So when will be my next save point? 11:05. Yeah. When the save point is executed, it writes back all the changes to what? To the disk. Let's say at 11:02. Now let's say now time is 11. We expect to have the save point executed at 11:05. At 11:01, let's say I create one transaction, new record into the table. So in the main memory, I've got 6 records. In the disk, I've got 5 records. At what is the time? 11:01. Again at 11:04, I created one more transaction. So there's one more record into main memory. So there are totally 7 records. But in the disk, it is 5 records. At 11:05, but during this point of time, does your page management identify the change? And logger will put the logs. So in the log volume, should I see 2 logs? They're saying that there's one log at 11:01, there's one log at 11:04. Okay, good. At 11:05, the save point is executed, and the two records which are there in the table newly added will be put onto what? Disk. Now the data in the disk and the data in the main memory is same. Suppose if I lose power now, if I restart, will those 7 records come back to my main memory again? I have no problems in this because my power is gone after my save point, so I've got no issues. So 11:05 now. Let's say at 11:06 again I'm posting one more record. Table in my main memory has got 8 records, and the table in the disk has got 7 records. And logger will have the new set of logs after every save point. It starts new set of logs. We'll have again new one log, which is of 11:06. Again, let's say 11:08. Again, I create one more. So 9 transactions in my main memory, 7 records in the table in the disk, and 2 logs in the log volume list. Okay. And let's say at 11:09 there is a power shutdown. At 11:09, for some reason, there is a shutdown of the server bus. Okay. So now did I lose my data? Because my main memory had 9 records, but my disk had only 7. So how does it get those records back? In a question. When I switch on the server, it loads a table from this disk to the main memory back. So you start getting the table with what? 7 records. Yeah. And then what are the logs which are captured in the log table? It re-executes those logs and starts getting those 2 other transactions, and main memory will have 9. So with this concept, HANA is able to satisfy the property of durability or persistency of data. Clear this? So this is how, by using save point, page management, logger concept, they do with what? The data persistency. Actual concept in this is all internal, but ultimately, how does it satisfy the concept of durability? Every read happens from main memory, but every write is being written back to what? Disk, whether it is through save point or through logs, it is writing data back to the disk. That's how, if there's some power, when you restart, you're able to get the data back what it was before the power shutdown. That's how HANA is able to satisfy the data persistence. And still to be on the safer side, again the data volume and log volumes are again taken a backup of it. You might say, if I lose this, then if I lose my log volumes again, then only backup again. Yeah, from the disk they'll be taking the backup from the data volumes and from the log volumes. You can also take backup from main memory also. We have flexibility on HANA. But taking backup from main memory doesn't really satisfy your purpose. It will be of this data volume or your log volume. not the main memory. Because when I have the backup of data volume, I can always restore it back to your main memory. And one more point is, I told when I restart the server, the tables are brought to main memory, right? In fact, actually, when you start the server, it does not bring all the tables to main memory. When you start the server, by default, all the system tables, which are row store tables, will be loaded to main memory by default. Okay? And when it comes to column store tables, are not loaded to main memory immediately. Only set the flag of those tables as preload, optional. When you creating table, if you set the table flag as preload, those particular column store are loaded. Suppose I have got a column store table where the preload flag is not set, that will not be loaded to main memory. It will be still in the disk code. And when you, let's say you fire a query on the table, let's say table has got 5 columns, but you're running a query with only 2 columns on the table. Now the data is not there in the memory. Now it reads from the disk, places now only those 2 columns into main memory and gives you results. And for the second hit, it starts reading from the main memory. అర్థమైందండి కూడా సర్వర్ స్టార్ట్ చేసిన మొత్తం అన్ని టేబుల్స్ లోడ్ చేసుకోదండి బై డిఫాల్ట్ ఇట్ డస్ లోడ్ ఆల్ ది రో స్టోర్ టేబుల్స్ and the column stores tables for which the preload priority flag is set up. If you switch on the preload priority flag, then the tables are loaded to main memory. If it is column store, if you have not set the preload, load loading into main memory, unload means remove from main memory. That's it. If you have not set the preload flag, those column store tables are not loaded to the main memory at all. During first query execution, those relevant columns are loaded to main memory. If I have a column store table with 100 columns, I fire a query with only 5 columns. Only those 5 columns are loaded. Not that is called partial loading. కొన్ని కాలమ్స్ ఉంటే టేబుల్ మొత్తం లోడ్ చేయదు ఓన్లీ ఆ కాలమ్సే లోడ్ చేసుకుంటున్నాం. దట్ ఈస్ కాల్డ్ పార్షియల్ లోడింగ్ ఆఫ్ నౌ because see, your main engine would be this one. You'll be taking backup of these ones. So this is almost like offline. When the server is up and running, it's all dealing with mainly with main memory. So these are available. You can take backup of them. Online backup can be taken. So and then you'll have something called metadata manager. Obviously, every application should have this, which takes care of what maintaining all the metadata. Let's say you create some table. Details of this stored into some repository table. That is all handled by your metadata manager. And then you'll have something called, you heard about SLT, SAP Landscape Transmission. That's a real-time replication server. So it's like a middleware server which can connect to SAP or non-SAP systems to HANA and then bring data in real time. Let's say I have a table. As soon as I do posting in the table in the source, I would get the table record into my HANA database. I can do some real-time replication of data through SLTs. So what happens now when you configure the connections through SLT, you can trigger the replication process from HANA. So that is what the replication servers are. Now when the replication servers are integrated to HANA, the replication processes can be triggered from HANA database. That is what the replication server is. So this and these HANA models or database of HANA can be exposed to business objects through SQL interface or through MD Express. And these all will be the sources, whether it could be SAP or non-SAP, you can extract it. And there is some legacy system which you're not able to integrate. You can also leverage BODS, which is an ETL tool. And for all this, like when you want to process your data in the server, you get connected to from what? HANA Studio get connected and you can start working on administration or modeling. You'll have different perspectives in HANA Studio where you can work as a modeler, work as an HANA developer, or BW modeling, about anything. Depends on the perspective what to work on. So you'll have design student and you will start working onto the server. This is migrate. I can copy. Say if I get into this BW modeling, I get connected to a SAP system. Second, back. You'll have info providers where it shows you info areas. I can see any of this advanced DSO. I can see the details, settings. You can see on it, and I can also log into SAP login. It does open your GUI, same as it's not. This is what you see. Yeah, you can go with creating, but see, this model would make sure you create all this advanced DSO, composite cloud, open DSO. But if you don't do the old modeling, you still leverage your modeling RSA1. In RSA1, you will not be able to create advanced DSO, not possible. It has to go with HANA modeling tools. Yeah. Yeah. I can also do with ABAP also same. Yeah. Modeling and HANA model. Ah, no, we can import or you can do that. See, there's something called. So this is an ODS which we imported. Yeah, if you see this, is a view which is you see this AZ demo 00. This is like active table of DSO. This is a DSO which is in, that's what you're referring. You can all there's multiple flexibilities of doing. You can import the DSO as article view, or in the DSO property settings you'll have checkbox for create Excel HANA view. Depending on the version, if it is BW731, you don't have the checkbox. You'll have to explicitly import it. And then if it is 7.4 SP5 or SP8 or SP11, you can obviously enable the checkbox, create external HANA view, which would create the views automatically. Now for DS1 analytical view, for Cube it also creates analytical view and calculation view also. Automatic publish station. And you can also import BigQuery also as a view. There's something called query snapshot. You can set in BigQuery as and import BigQuery as analytical view also. Cube, DSO, then you BigQuery. And the mount F table, all F table, SI tables, all those join you get. ఇది ఒక cube. You see this, see, you able to see this F table, dimension tables, SI tables, now you see it. See, if you still, so this is your table, which is what that SID is to the SI tables, and your X table, what is it? Navigation attribute tables, and from there to your SID tables, text tables. This is can get, and whether the attributes come in or not, there is one checkbox for importing. If you say include display attributes, even attribute tables come. You do like this: file import, HANA content, and you see import BW models. Then you start giving some connection beat. You get to select something. DS1. I'll just add it and then I'll specify the package and it's import. While importing, I can say include display data, so it does include mask data. Yeah, next. So next we're trying to understand different components of HANA. In HANA, what all components we have and what kind of functionalities can be performed in HANA. So with this, when you look at some business requirement, you will be in a position to recognize, okay, for this kind of requirement, I will be able to leverage HANA. ఎలాంటి సినారియోస్లో నేను HANA వాడుకోగలుగుతాను అని ఏమేమి చేయొచ్చు HANAలో అనే పాయింట్. Now let's say this is my HANA database, yeah? And I can integrate or I can import data from SAP or non-SAP systems into HANA by connecting through SLT, real-time replication servers, or through BOTs. By leveraging BOT or SLT servers, I can import or replicate my data from SAP or non-SAP systems into HANA database. So you do have flexibilities in HANA where I can do the data provisioning in through SLT or through BOTs. There are other mechanisms, but that's one of them. Yeah. And there's something called in-memory database. So HANA is an in-memory database. It does store data in main memory and process it to give you faster results. Then there's something planning and calculation. Now, let's say in case of BW on HANA, let's say in BW, do you have IP integrated planning? In BW, by installing something called planning kit, I can push down the logic of planning functions into HANA as a stored procedure. You do not go to write anything. If you just install the planning kit, automatically, if you basically install the planning kit, automatically the logic of planning functions will be installed into HANA as a stored procedure. Thereby, you are putting pressure of executing planning functions into HANA data. That is like planning engine. And when we heard about calculations just now, which will execute all the complex calculations in calculation engine. We'll have something called C functions and Konultai. So we'll see them. But by using for more frequent written select statements, SAP has given some C function with specific syntax. When you write C function, straight away the logic gets executed into calculation engine. Then we'll have something called predictive analytics library and business function library, which is nothing but the ready-made functions there. So for certain logics, they have built up ready-made functions with C++ as a language, and they deliver you functions like a stored procedure. You just have to call them with all the input parameters what they need in and collect the results. Like say ABC analysis, linear regressions. There's a lot of functions for which they have given ready-made functions, which we call them as predictive analytics library. For predictions, you can use it. For business function libraries, you can just have to know the procedure what is there, and then call the procedure depending on the parameters, and then collect the results. Yeah, we do have that flexibility. Then we have something called R integration. R is actually a language. Okay, so this is what I do. When I want to write some data-intensive logic, I would write a stored procedure by using SQL script. I can also implement stored procedure by using R language also. So we have flexibility of integrating R on our database also. Generally, they use R preferably for when they write some logics of statistical processing of data or predictive analytics. They use more of R language. Okay. And then there's something called Hadoop integration. So you would have tight integration between Hadoop and HANA database. See, actually going forward, future would be this. All SAP would be onto HANA. All non-SAP data, they try to bring it onto Hadoop, and Hadoop gets integrated to HANA data. That's going to be future. Now, when you fire a query HANA can do some searching onto Hadoop and get you results. Hadoop would have like some search engines. You can do search your database and then get the results and then gives you the orange logo. So we do have something called smart data access, which is not listed out here. There's something called smart data access through which you can remotely connect the systems into my HANA database. Say, for example, I can connect SQL Server database to HANA. I can connect Hadoop to my HANA as virtual table. Access Hadoop content into my HANA database virtually. Or ECC system to my HANA database virtually. With the help of smart data access, I can still integrate Hadoop system to my HANA database. Non-SAP data to Hadoop, all SAP data into HANA, and Hadoop gets integrated to HANA, and then reporting will be on HANA. So when you fire it, and all the objects of Hadoop will be referred as virtual objects in HANA database. When you fire a query onto this virtual object, they indirectly read data from Hadoop systems. Because let's say if you look at a customer like BMW, who's got around 420 applications. Now, does it make sense for me to bring all 420 into HANA? No. So what they do, they will start having SAP data into HANA, and non-SAP data, they get into distributed file systems into Hadoop, and Hadoop gets integrated with HANA. So there will be only base for me. I'll be least bothered about what is happening in the applications. All my applications data in my Hadoop and all my SAP applications data into HANA, then integrated, and this will be like a back-end bone for any reporting. అలా చేస్తాడు ఫ్యూచర్ అట్లా వెళ్తున్నారు ఎందుకంటే అడూప్ వాట్ ఈజ్ మై నెట్ సేల్స్ అని సెర్చ్ కొట్టి డేటా వస్తున్నాం ఆ రేంజ్ లో ఇట్ హస్ గాట్ ఓన్ సెర్చ్ ఇంజన్ ఇంటూ ఇట్ అడూప్ సో అది వాడతాడు యూ కెన్ ఆల్సో గెట్ త్రూ స్మార్ట్ డేటా యాక్సెస్ యూ క్యాన్ కనెక్ట్ బట్ ద డేటా వాల్యూమ్ విల్ బి హ్యూజ్ కాబట్టి ఆ రెగ్యులేట్ అంటే ఎట్లంటే ఫర్ ఎగ్జాంపుల్ ఐ హావ్ ఈసీసీ విత్ HANA. Future what happens, multiple applications sitting on single HANA database వస్తుంది అప్పుడు అలా multiple applications sitting on single HANA platform. It will have all the SAP data already. I don't have to do any provisioning, nothing. Already all my data is sitting in it. And non-SAP data, I'll push it to Hadoop first. And that Hadoop gets connected to this HANA database virtually. Now I've got all SAP data in it. I've got non-SAP data able to access virtually. Then this will be exposed for report. No, you want this one. Or at least future నేను చదవడం బట్టి అలా ఉంది అని నా ఎక్స్పెక్టేషన్. And then there's something called text search or text analysis, which we do for processing of unstructured data. Let's say you got very big text and you want to break down them into tokens and you would like to analyze them and do analysis on sentiments. How many are, let's say you get some reviews and you would like to do some sentiment analysis. I can go with what? Text search. Yeah? Search concepts into this. Say for example, you heard about this Ajax. In Google, when you type in something, it starts showing you relevant topics below. Alaga, when you're developing say HANA native applications, you're typing something, you want to get those the possible text below, which we call it as fuzzy search. Fuzzy search is like fault tolerant search. If I say show me records from this table where my country US and it's like you're matching to the exact string. నాకు అట్లా ఉంటే సెలెక్ట్ స్టార్ ఫ్రమ్ దిస్ టేబుల్ వేర్ మై కంట్రీ కంటైన్స్ యూ అని వేర్ ఫజీ సర్చ్ వెయిటేజ్ సో అన్నారంటే ద మోర్ ద వెయిటేజ్ ఇస్ యూఆర్ గోయింగ్ అవే ఫ్రమ్ ద స్ట్రింగ్. ఇఫ్ యూ రెడ్యూస్ వెయిటేజ్ యూఆర్ నియర్ టు ద స్ట్రింగ్ అంతే. సో బై వి కాల్ దట్ స్కోర్. If the score is high, it also results in some strings which are not really exactly matching also. Even if I search say SAP, and a lot of things like SAP Technologies, SAP Infotech, SAP GDC, SAP Germany. If I say my weightage is let's say 7.0 or 8.0, it starts from 0.0 to 1. 1 is max, never matches it. If it's a 0 point, SAP string, as soon as you type SAP, it starts giving you all those relevant strings. So it's not exact match. Fault tolerant search. కొద్ది మ్యాచ్ అని చూపియన్నట. ఎంత మ్యాచ్ అయితే చూపియాలి అనేది వెయిట్ స్కోర్ ఉంటుంది మనం. 0.0 అంటే ఎగ్జాక్ట్ మ్యాచ్ అయితే చూపిస్తాం. ఆ నంబర్ పెరిగే కొద్ది కొద్ది డీవియేషన్ పెరిగే కొద్ది కూడా చూపిస్తాం. And then there's something called application service. That's what I was telling you. It has got its own access engine where you can develop your own applications using UI5 or native framework or non-native framework and deploy it on what? Access engine. And then this 2 days, like I told you just now, it's a client-based application. You get connected to HANA server and start working on it. Yeah? And then there's something called information composer, which is will be leveraged by end users. Let's say you modeled a view through which they can use it for report. Now let's say they have something called product in the view. Now business users, apart from this product, you would like to have one more column which says say product classification as A, B, or the list of products. Along with product, you would like to have one more column for reporting which says product classification. But that is not there in my database. Then you would give me that requirement. Then I would say it would take 3 months of time to development bug, then unit testing, then transporting, integration testing. So the time taken to develop that requirement takes a lot of time. Then what you can do is we can expose this view for this guy. From the Excel file, you can upload the data and then form a local provider. Then connect that local provider to this view and he can join the file to that view and format an extra column and then use it for report. You need not wait for you to do the development. It is similar to your BW workspaces, and here we refer to it as information composer. It's an end-user based tool where you can do user-specific modeling. Okay. It does not reflect it everyone. Only for that particular user, it reflects the change, and you can see. And all this data can be exposed for the reporting. It could be an Excel, business objects, any reporting tool which can consume SQL interface or MDX objects. And the reporting could be done in real time. So if you are leveraging SLT, you bring real time data into HANA and top of it do real time reporting. See, HANA as it is not real time. It's a normal database. When HANA is accompanied with SLT, it starts giving you real time data. And I can accompany SLT to BW also. SLT is like a middleware server which can read data in real time from the source and push it to any target. It can push it to BW or it can push it to HANA also. So if you want to go to pure HANA just for SLT, need not. I can have SLT configured to BW also. That's why BW on HANA still holds good. That's what. Okay. And if you look at the different HANA software availability, you can go buying a platform edition or enterprise edition or the extended enterprise edition. When it's a platform edition, you just get mainly the database and the agent and the libraries. But if you buy about enterprise edition, you get the database and the DXCs and SLTs also, and the SAP SLT replication mechanisms. If you buy an extended enterprise edition, you get all this, plus you get something called Sybase replication. There is something called Sybase replication mechanism through which you can also replicate data in HANA, even you get that mechanism, or servers also. So depending on what, and each one will have different charges. For one user license, it is 6 lakhs. Okay, now lower discount is free good. If you are so much valued customer, also give you free. The latest charge mechanism no fixed rate. Based on the turnover of the customer, in the percentage is my cost. Like 1 crore turnover rate, 2 crores now charge at 3 crores. And depends on the level of customer. If it's a big customer, Tramco or Reddy Labs, while dedicated support team. Now Reddy Labs, if they don't raise voice or something, straight away they'll call, Nagi soon fix cheyala. Inka endante, suppose you create some Z program, but generally SAP doesn't support it. For these customers, you write Z program, Y program, anything, they have to support. At different agreements, customer, but very annata. Your network atla. Yeah. Now it is going, they're charging on the turnover basis. Okay. You've seen this other day. How can we leverage HANA? So what is this HANA leverage as data models? You will install the separate database. Through data processing techniques, you bring data into tables and start building HANA models and then do reporting. Yeah? Then when I say HANA as database, you can use this HANA as a database of the existing SAP applications or non-SAPs also. But I can have now from BW 7.3, I can have BW being with what? HANA as a backend database. And HANA as accelerator means you install HANA as a separate database, push all the relevant processing of data. Let's say you want to improve certain functionality of certain business process. And what are the tables are necessary to process this business process or business functionality? Push them into HANA, config, customize your ABAP programs to refer to the second database and start improving the performance of those applications only for that particular process. And HANA Cloud with single infrastructure getting shared by users, multiple users. Then when I say mixed approach, let's say you have BW with HANA database in the backend, and the same HANA database is used as a data marting also. So HANA will have BW schema and non-BW schema also. And when I say HANA native developments, you go about using HANA native framework or non-native framework. You develop your own custom applications for business requirements and then deploy it on existing. That is HANA native development. So you could go over working on any of this. You would cover all these options. So your job requirement could be anything. We are there. So our code should fit into every aspect. Okay. See, they're using different vocabulary. They're saying SAP native, SAP HANA enterprise, SAP HANA data mart is all about installing HANA as a centralized database, getting data provisioning, building models and reporting. Adi SAP HANA Enterprise, like SAP Native HANA, like SAP HANA Data Mart. Okay. If you say SAP HANA Native Development Application Development, then that is developing framework of UI services and databases. And database is from here, BW form that you get. What happens is HR would do the screening, do not understand anything more. Even ultimate డేటా మార్ట్ హనా బీడబ్ల్యూ తెలియదు కాబట్టి మనం ఏంది హనా అంటే నేను ఉన్నాను అది కాన్సెప్ట్ నువ్వు ఎట్లా పడుకున్నాను నాకు హనా వచ్చు యూ కెన్ యూజ్ మీ ఎనీ వే యూ వాంట్ వెదర్ యూ వాంట్ మీ టు వర్క్ ఆన్ డేటా మార్ట్ ఐ కెన్ స్టిల్ డూ దట్ యూ వాంట్ మీ టు వర్క్ యాజ్ అ బ్యాక్ ఎండ్ ఆఫ్ బీడబ్ల్యూ ఐఎమ్ స్టిల్ దేర్ యూ వాంట్ మీ టు వర్క్ యాజ్ హనా ఆన్ ఈసీసీ పవర్ పైన ఐఎమ్ స్టిల్ దేర్ హనా డెవలప్మెంట్ ఐఎమ్ స్టిల్ దేర్ అప్పుడు అన్నప్పుడు వాడు హనా అంటే చాలు మనం రైట్ రైట్ ఉన్నాను రైట్ బికాస్ నేను ఫేస్ చేసిన when I was attending some interviews, నేను బీడబ్ల్యూ పోవడం కాదు మాది ఇంటర్వ్యూస్ అన్నా మాకు ఇతర కానీ తెలియకుండా స్కెడ్యూల్ ఇంటర్వ్యూ వితౌట్ నోయింగ్ అని నేను మనం వదిలికూడదు మనకు జాబ్ was ఇంపార్టెంట్ అది కూడా ఓకే చెప్పుకోండి ఐఎమ్ ఓకే ఈవెన్ విత్ దట్ ప్లీజ్ కంటిన్యూ ది ఇంటర్వ్యూ అంటారు సో అప్పుడు అందుకే నేనేమంటానంటే సో వెన్ యూ మేజర్ వీ షుడ్ డీల్ విత్ మిక్స్డ్ అప్రోచ్ సో దట్ యూ కవర్ ఎవ్రీ ఆస్పెక్ట్ యూ కవరింగ్ HANA as database for BW and the same HANA database is leveraged as data mart. And let's say for some of the reports, we have to practice scenario. And BW HANA, we have the easy one. Kana covering this scenario. So, what I because I love that and we'll get into discussing on HANA Studio and start getting into learning and